For each function described by the equations and graphs shown, indicate whether the function is even, odd, or neither even nor odd by selecting the appropriate letter in each cell. Note, complete the problem and then enter all letters A through I. Alright, so this looks like it could be even. Let's test it out. If a function is even, that would mean that f of negative x equals f of x. So if we do plug negative x in here, that would become 3x squared again, since negative x squared is positive x squared. So yes, f of x is even. Now let's try g of x. G of x looks like it could be odd since there are odd exponents, but in order to be odd, g of negative x is going to have to equal negative g of x. So let's test that out. If we plug in negative x here, we would get negative x cubed plus 5. That would become x cubed plus 5, which does not equal negative g of x, which would be negative x cubed plus 5. That would end up being x cubed minus 5. Since these are not equal, g of x is not even or odd. All right, moving on. We have a graph here, and we can see that this function is symmetrical across the y-axis. So that means that it is even. And this last graph we can see is symmetrical about the origin. Because if you take any point, go through the origin, over there you'll see it is equidistant. These two little segments are equidistant and there's a matching point on both sides. So from that point over to that point, yes, this graph is symmetrical about the origin, therefore it is odd.